Welcome to the first video of this playlist. In this first video, I'll talk about, or we'll do an exercise, of course, but I want to show you something before. So this is the blog post that you can see on this link here. It's written by David Rutten, is the same author for Grasshopper. He's the father of Grasshopper. And he explains the component called Galapagos, which we'll be using in this playlist and with various exercises. So it's basically kind of an implementation of an evolutionary solver inside of the Grasshopper, and it helps us to optimize or find solutions based on the given design constraints. And you can read a lot of different details related to this component or tool called Galapagos. But let's start our exercise. So what we are going to do today is, let me minimize myself. So let's start with something super simple. Let's draw a curve. Okay, let's draw a curve and let's find the minimum or the maximum or lowest and the highest point of these curves. Let's say this is our curve, and if I go to curve and the analysis, I can find the extremes, and when I connect this, I put the extremes, so it gives me the highest and the lowest point. So this is something we already know, or we can always solve by like the native components of Grasshopper. This is kind of an easy problem to solve, right? Because we can easily detect the highest point. Let's visualize this point. Maybe like a dot display. This is going to be our point, and we can also use symbol. Okay, size, size, rotation, color, and this is going to be our symbol. It's a pin. And we see the pin here. Oh, we don't see the pin here. And maybe symbol display. This is the location. You can take this off and take this off too. And the style is, if you right click to pin, we can have it pin, like let's say 5. Put this there. You see we still have it, but it's super small, so maybe 50, because we need to see it in a distance. Oh, that's too much. 10 might be okay. All right, so this is our point, right? And we can see that point. And if we want to do the same thing with Galapagos, what we need to do, because now this is our constant, so we know this is the highest point of this curve. We want to do the same thing by using Galapagos. What I'll do is I'll grab this curve again, okay? And then what I'll do next is to find or how we can find the point of this highest point on this curve is if we evaluate this curve, reparameterize it, and let's say changing between 1 to 2, 1 to 0, right? So you see I am changing it and it tries to find the location, so I can preview this off. So, and if I find another like a display for this, maybe I can do, I don't know, like not that one. Style might be triangle, or I don't know, arrow that goes up maybe. Let's put 90 and 3 radians, sorry, and put this in, and see it's showing me this point, and the color we can put white here. Size might be a bit smaller than this. So this is the visualization, so I can now view stuff. So what is Galapagos? So if I go to prompts under input, sorry, under, I go to prompts Where is Galapagos? Util, yes, sorry, under util we have Galapagos. So what Galapagos has is actually two information, right? One is fitness, the other is genome. Genome is the one that we use to connect our sliders to create our populations or population of solutions. Fitness is the value in which we are trying to find or optimize. So if I deconstruct this point, and in this case, what we'll be using for is its Z component, right? It's Z value. So if you can find a number here, and this is going to be our fitness value, and our genome is going to be this slide, all right? And if I double click to this, you see we have this menu pops up. It has options. Fitness value you want to maximize or minimize, or you can type a value here. You can say 0, you can say 10, but in our case we want to maximize. If you want to have sort of a threshold, you can put it there. You can run it with sort of a time limit. There are some like different solution spaces, like evolutionary solver or annealing solver. We'll be using evolutionary solver, and it has some information that you really shouldn't be worrying about right now. We might need to explain this in the further videos, but for this playlist I don't think we'll need details from this end. And we can come over here. There are two solvers, as I said just a couple of seconds ago, evolutionary solver and the annealing solver. We'll be using evolutionary solver. If we click on this, you see that start from slider setup, start from select the genome. We don't need these. We can start the solver, and this is sort of important. Display all genomes in the Rhino viewport. So what this means is if you change anything in the slider, all the results would be visible here. This might be tricky if you're doing a heavy kind of calculation with like a lot of colors and meshes or geometries. You may want to turn this all off. Okay, and this is the about page I just showed you the beginning, so it's basically the blog post. All right, so we want to see everything, and when we start solver, so let's see what we are going to see. So when we start the solver, you see it's creating all these, like it's adding all these solutions here, and what it does is basically giving us some populations, meaning solutions, and these are the basically the solutions that we see graphically here. And as you see, since we have only one single slider, it has one directions, so it goes only top. And you can also say display display the top 50% genomes, top 25, top 10, or additional mutations to the populations. I'm not really sure what this does. So we can see all the solutions. And what we are seeing here is basically some results, right? Some results that are coming from our genome, which is for our slider. And if I select this and if I reinstate this value, what we'll see that it's basically reinstating that value in terms of its Z boundary or Z organization, meaning it starts with this value, and then it's basically what this does is it guesses, checks, and adapts. So it sees there might be a better option, reinstate that one. There are better options, until it finds our solution. But you see, when we zoom in, we don't see the problem, or we don't see the exact highest value here, because what this does is it approximates the value, because we didn't give it a value of, let's say I don't know, like 10, 20, 50. So it's basically great at approximation and leading you towards a better solution, but it's not that great when you put the option as maximize to give you an exact information or an exact solution or an exact result. Therefore, we have to be really careful on when we use Galapagos and how we use Galapagos. And with this being said, I think we are finishing our first video. And in the next video, we'll be talking about a better example on how we can use Galapagos.